We are now going to look at some other examples. We're not actually going to do the calculation for them, but consider what equation we might use to calculate the energy at the start point, which store this energy will have transferred into by the end point, and what interesting things we could calculate by knowing that the energy at this end point is equal to the energy that we calculated at the start. So our first example is dropping a ball, and for this example we're going to start with the ball stationary at the top, and the end point is just before the ball hits the ground. So think about those questions. What equation can we use to calculate the energy at the start point? Which store will the energy have transferred into by the end point? And what interesting thing could be calculated by knowing that this endpoint energy is equal to the energy calculated at the start? Pause the video and have a think about those. Okay, hopefully you realised that this is essentially the same question as the minor that we looked at, that we can calculate the energy at the start point using the gravitational potential energy equation. And then by the end point, just before the ball hits the ground, all of that energy will have transferred into kinetic energy of the ball. And therefore, like with the minor, we can calculate the speed that the ball will hit the ground at. Okay, let's move on to a slightly trickier example. Okay, in this example, we're going to consider releasing an elastic band horizontally, and our start point is going to be the stretched elastic band before it's released, and our end point is going to be the elastic band just after being released. So let's watch that. Okay, so like before, the questions that I would like you to think about are: what equation can you use to calculate the energy at the start point? Which store would this energy have transferred to by the end point? And what interesting thing could you calculate knowing this endpoint energy is equal to the energy calculated at the start? So pause the video and have a think about those questions. Hopefully you've realised at the start point you can calculate the energy as elastic potential energy, and that at the end point just after being released, this energy will have transferred into the kinetic energy of the elastic band, which means, a bit like with the minor and the ball drop, that we could calculate the speed of the elastic band. Now let's move on to our third example. In our third example, we're going to think about firing an elastic band vertically up. So the start point will be when the elastic band is stretched and stationary before release, and the end point is going to be the highest point that the elastic band gets to. Let's watch that. There we go. Okay. So once again, I would like you to think about what equation can be used to calculate the energy at the start point, which store will this energy have transferred to by the end point, and what interesting thing could be calculated by knowing the endpoint energy is equal to the energy we calculated at the start. Pause the video and have a think about those questions. Okay, hopefully you've realised at the beginning the energy was in as elastic potential energy, so we could use the elastic potential energy to get the initial energy. When the rubber band reaches its highest point, all of that energy will have transferred into gravitational potential energy, and therefore we know that gravitational potential energy here is going to be the same as elastic potential energy was at the beginning. And knowing that, the interesting thing that we could calculate is how high the elastic band would go. This question, or this example, is a good one to illustrate the importance of choosing your start and end point. Because actually, although the energy will have transferred through being kinetic energy during this, that doesn't really matter because we are only interested in the start and the end. So we don't actually need to consider kinetic energy at all, because at the start, all the energy is elastic potential, and at the end, it is all transferred to gravitational potential. Hopefully, looking at these different examples has helped you to see this general approach of choosing an equation to calculate the energy in one store at the start, using conservation of energy to say a little bit later exactly the same amount of energy will have shifted into another energy store, and then finally knowing the energy in that different store to calculate something interesting.